To finish off Chapter 8, that combines our work in Chapter 7 with confidence intervals and our work here in Chapter 8 with our hypothesis testing. Notice our confidence interval formulas here. One has a z-score because we have the population standard deviation. One has a t-score because we have the sample standard deviation. So recalling our z-score comes from Table E. Those are our 1.65, our 1.96, our 2.58 numbers that we've come accustomed to seeing. Our t-scores, because of the sample standard deviation, come from Table F, and they're based on degrees of freedom along with our interval level. Other than that, we're going to construct an interval along with our hypothesis testing process, which essentially is going to verify our results. It serves as a check-off procedure. So down here, notice it says if the desired population mean is not in the interval, reject the null. So if our mean doesn't fall between these two numbers, we should reject the null. If our mean does fall between these two numbers, then we don't reject the null. And that will kind of tie in with our test score and our critical values in steps 2 and 3 of our interval. So we're basically adding a sixth step to this process that will verify what we've done up here in steps 1 through 5 by constructing an interval and see whether or not we made the right decision to reject or not reject the null. So here's our first look at that. Sugar is packed in 5-pound bags. An inspector suspects the bags may not contain 5 pounds. A sample of 50 bags produces a mean of 4.6 and a population standard deviation of 0.7. So population standard deviation tells us to use Table E. Is there enough evidence to conclude the bags do not contain 5 pounds, as stated alpha equals 0.05, and we'll also find the 95% confidence interval level. So we'll start with our hypothesis testing process. Step number 1, notice we are back to testing the mean based on a mean of 5 pounds. They may not contain, so equal to and not equal to. And is there enough evidence to conclude the bags do not contain 5 pounds? So there's our claim. Step number 2, two-tailed test. So on our curve, we have a shaded area on both sides. I'm going to use a traditional method. So when we go to 0.05, we have 0.025 in each tail. We'll go to Table E. Table E, let me get rid of this. Having a brain cramp here. Table E. And I have to scroll back up a little bit. Table E will find 0.025, and 0.025 is an exact number this time. It's negative 1.96. So those will be our two critical values, negative 1.96 and 1.96. We'll move on to our test score. Our test score is a z-score. Our sample mean was 4.6. Our population mean is 5. Our standard deviation is 0.7, and our sample size is 50. We'll plug those in to get our test score. As a reminder, with our calculator usage with our parentheses, and that test score is negative 4.04. Negative 4.04 is going to be way over here, which is going to tell us to reject the null and to support the claim. Now, as I said, we're going to introduce a sixth step here. That's our confidence interval. So our confidence interval is our sample mean, 4.6, minus our z-score for 95%, which is 1.96. Standard deviation is 0.7, and our sample size is 50. And we'll construct that mean around the population mean, 1.96 over 0.7 over the square root of 50 here as well. And if we construct that, we get 4.41 and 4.79. So notice that our population mean of 5 does not fall between those two numbers. So 5 is not in here, which means we reject the null, which is what we did. So I'm going to go back up here. If our population mean is not in the interval, reject the null. So as I said when we started here, step number 6 essentially verifies our results that we made the correct calculation and correct decision up here to reject the null. We'll go one more time with that idea. Researcher claims that adult hogs fed a special diet will have an average weight of 200 pounds. A sample of 10 has an average weight of 198.2 pounds and a standard deviation of 3.3. So notice our sample of 10 has a standard deviation of 3.3. That's an S, or we're now using table F because of that sample standard deviation. At alpha equals 0.05, can the claim be rejected? Find the 95% confidence interval level. So step number 1, we're working with our mean of 200 pounds. Our mean of 200 pounds will have a weight of 200, so equal to and not equal to. Read back through here. Researcher claims that adult hogs will have an average weight, so here is our claim. It's again a two-tailed test, which actually winds up being given us a shortcut that I'll talk about here in just a second. Degrees of freedom are 9. So I'll put our two tails on here and shade. We'll go ahead and go to our table 0.05 and a two-tailed test. Notice we're using table F here. So let's scroll down to table F. Two-tailed, and we had 9 degrees of freedom at a two-tailed of 0.05, and that is 2.262. There's our two critical values, a positive and negative version of that. So I put negative 2.262 on this side and 2.262 on this side, just marking that 0 falls down the middle. Our test score is our sample mean of 198.2 minus our population mean of 200, our standard deviation of 3.3, and our sample size is 10. Putting our parentheses in again as a reminder, and we get a test score of negative 1.72. 1.72 or negative 1.72 falls between 0 and negative 2.22, which in this case will tell us to not reject the null. And step number 5, because we did not reject the null and the null is the claim, there is enough to support the claim. Enough evidence, I should say. I left the word evidence out. Step number 6, we're constructing our confidence interval. So I mentioned a little bit of a shortcut with a two-tailed test. When we construct our interval, the critical values that we found up here will be the t-score or the z-score that we use down in here for our two-tailed test. So our interval, our sample mean is 198.2. Our test score, our t-score is 2.262. Our standard deviation is 0.7 and our sample size is 10. And we construct an interval for each side of our interval. 2.262, 0.7 over square root of 10. If we make that calculation, our confidence interval runs from 195.84 to 200.56. Notice that our population mean of 200 does fall between these two numbers, albeit barely, but it does fall between there. So that tells us that we should not reject the null. I'm going to go back a page. If the desired population mean is an interval, do not reject the null, which is what we did here. So I mentioned step number 6 serves as a check-off procedure to make sure our 5 steps were correct and we didn't make a mistake in the calculation or critical value stage of that. And there is the end of Chapter 8.